Hello, my dear students. How are you? I hope that you will be very fine, and I am also very fine. Today, I am going to discuss the question bank of IIT, and the chapter name is kinematics. In last class, I have discussed about work per energy. I have discussed about work per energy, and today I am going to discuss the problems related to kinematics. Now I am going to start one by one. Here, first question is two balls of different masses are thrown vertically upward. Here, two balls of different masses are thrown vertically upward with same speed. With same speed. Both balls have different masses, but their speeds are same. They pass through the point of projection in their downward motion with same speed. Neglect air resistance. Suppose two balls of different masses. I have already taught you in same horizontal line. Upward velocity and downward velocity of same ball will be same. If you project a ball having velocity 20 meter per second, then what will happen? Then its velocity will decrease. Acceleration is 10 meter per second square in downward direction. This means that 10 meter per second divided by second. This means that velocity of the particle will either increase or decrease according to the direction of velocity and the direction of acceleration. If the direction of velocity and accelerations are opposite, then magnitude of velocity will decrease. If the directions of velocity and acceleration are same, then magnitude of velocity will increase. Here, direction of velocity and acceleration are opposite, therefore velocity will decrease by 10 meter per second in each second. Therefore, in next 1 second, its velocity will become 10 meter per second, and this velocity becomes 0 in further 1 second. Okay, final velocity will be 0. Now the ball will not move upward because its velocity is 0. Now the ball moves in downward direction. Whenever the ball moves in downward direction, then the directions of velocity and acceleration will be in same direction, that is in downward direction. Therefore, magnitude of velocity of particle will increase by 10 meter per second in further 1 second. Therefore, actually the particle hold down on the same line, but for clear visibility, I show this motion on this line. Particle moves in downward direction. After 1 second, its velocity becomes 10 meter per second, because direction of velocity will be along the direction of acceleration. Therefore, velocity of the particle will increase in each second by 10 meter per second. Therefore, the velocity of this particle at this position will be 20 meter per second, because its velocity will increase by 10 meter per second in each second. Okay. Therefore you can see that in same horizontal line, upward velocity and downward velocity, magnitude of upward velocity and magnitude of downward velocity are same in same horizontal line. Okay. Here velocity does not depend on mass. If we consider motion from A to B, then we can apply equations of motion. V is equal to U plus AT. Here this motion is independent of mass. This equation is independent of mass. Therefore, I can say that velocity of the particle does not depend on mass. It only depends on acceleration, not mass. Therefore, in same horizontal level, upward velocity will be equal to downward velocity. Two balls of different masses are thrown vertically upward with same speed. They pass through the point of projection in their downward motion with same speed. Okay. Magnitude of velocity is called a speed. Here we observe that velocity in upward direction and velocity in downward direction along same horizontal line are same. Actually, this line is on this line, but for clear visibility, I have shown at this position. Therefore, this statement is true or false? This statement is true. Okay. If air is negligible, neglect air resistance means air is negligible, means air is absent. In other word, I can say that air is absent. If air is absent, then time of ascent will be equal to time of descent. Here we can see that time taken to go from A to B will be 2 seconds. This is 1 second and this is 1 second. Total time taken will be 2 seconds. And during the motion of the particle in vertical direction, this is 1 second and this is 1 second. Therefore, time of descent is equal to time of ascent. Time of ascent is equal to time of descent. But if air is present, then time of descent should be greater than time of ascent. Okay. This type of question can also asked in your examination, such as NEET or IIT. Therefore, you remember this concept also. If air is present, then time of descent is greater than time of ascent. Why? This is because when a particle moves in vertically upward direction, okay, when a particle is thrown in vertically upward direction, then a gravitational force acts on the particle which is equal to mg, and another force which is exerted by air called as air resistance. This also will be in just opposite direction of velocity of the particle. Okay, therefore resultant force in the one direction is large. If force is large, then acceleration is large. If acceleration is large and the direction of velocity and direction of acceleration are opposite, therefore if acceleration is large, then velocity, magnitude of velocity will decrease fastly. Okay, therefore will decrease fastly to zero. Therefore time of ascent is very small. Time of ascent is small. But if the particle returns towards the earth, then velocity will be in downward direction and gravitational force will be in downward direction. Air resistance will be in upward direction. This is air resistance. Okay. Therefore, resultant force in downward direction will be mg minus fa. This means that this force is very small. If a resultant force is small, then acceleration of the particle in downward direction is also small. Here we can see that the directions of velocity and the acceleration are same. Therefore, its velocity increases, but acceleration is very small. Therefore, its velocity will increase slowly. Therefore, in this case, time taken to fall the particle will be more than previous. Okay? Therefore, time of descent will be equal to, therefore time of descent must be greater than time of ascent. Okay? If air is present, then time of ascent is greater than time of, if air is present, then time of descent is greater than time of ascent. But if air is absent, then both will be equal. That is, time of ascent is equal to time of descent. Here you can remember it. Here you can remember it in simple way, in alphabetical order. Which comes first? A comes first. In counting numbers, which comes first? 1 comes first, and then 2, and then 3. Okay? Which comes first? Which is less? 1 is less than 3. Similarly, A comes first in alphabetical order. Therefore, A is less than D. Therefore, D is greater than A. In this way, you can remember it. Time of descent is always greater than time of descent if air is present. Okay. Now I am going to solve question number 2. A projectile fired from the ground follows a parabolic path. path of projectile will be parabolic. I know. Path will be parabolic. Okay. The speed of the projectile is minimum at top of its path. This is top. Top of its path. The speed of projectile will be minimum. Is it correct or wrong? Is it correct or wrong? This is correct. We assume its velocity u and angle is theta. Therefore, component of this velocity along this direction will be u cos theta and this direction will be u sin theta. Okay. Acceleration of projectile in downward direction. Therefore, component of this acceleration in horizontal direction will be g cos 90. What is the value of cos 90? 0. Okay. 0 multiplied by anything will be 0. Acceleration of projectile in horizontal direction is 0. Therefore, velocity along horizontal direction is constant. Therefore, at each point, particle has constant velocity in horizontal direction. U cos theta. Here also it is u cos theta and here also u cos theta. Okay. At any point, the particle has velocity in vertical direction also, but there is a single point which is at top, at which the particle has only one velocity, which is in horizontal direction only, but in vertical direction its velocity is 0. Therefore, we can say that the projectile has minimum velocity at top point because its one component is 0. This is minimum velocity. But another points except this point, particle has two components. One component in horizontal direction which is constant and other component in vertical direction. Therefore, velocity at all points except this point will be larger than u cos theta. Therefore, at highest point, the projectile has minimum velocity and it has only one component u cos theta in horizontal direction. Therefore, this statement is correct, true. Okay. Now I am going to solve question number 3. This question is based on assertion and reason. For an observer looking out through the window of a fast moving train, the nearby objects appears to move in opposite direction to the train, while the distant object appear to be stationary. You can observe from the window of a moving train. If you moving on a bus, if you moving through a bus, then you observe through the window of the bus, then the road will moves in opposite direction to the direction of moving bus, and distant objects appears to be stationary. Okay, just like train. Reason is, therefore this statement is correct. Okay, you can observe in daily life. if you going on a road, if you going on a road by a bike, then you can observe the road moving in backward direction. Reason is if the observer and object are moving at velocities v1 and v2 respectively with reference to laboratory frame, the velocity of object with respect to the observer is v2 minus v1. This is also correct. Relative velocity of 2 with respect to first, this will be equal to v2 minus v1. Here there is no mention, means velocity of particle 2 with respect to ground. Okay. Therefore both statements are correct, but reason is not correct explanation of assertion. This option is correct. Now I am going to solve question number 4. If particle moves in a circle of radius r, a particle moves in a circle of radius r in half revolution. This is circle. This is circle. In half revolution, its displacement is. A particle moves in a circle of radius r. Suppose this particle is initially at this point and it is moving like this. When it moves half revolution, then its displacement will be initial to final. This is displacement. Displacement is also defined as the shortest distance between initial and final position. Therefore, displacement will be 2r. Okay? Did you understand or not? Yes. Now I am going to calculate distance covered. What will be distance covered? The actual measurement of path followed by a particle. Particle is moving along this path. Therefore, we measure the length of this path. The measurement of this path will be pi r, because total circumference of the circle is 2 pi r. Half circle, particle moves half circle. Therefore, distance covered by the particle will be pi r. Okay. Now I am going to solve question number 5th. 4 persons K, L, M, N are initially at the 4 corners of a square of side D. Okay. This is a square. Separation between, each length of each side is D. 4 persons. One person is here, other person is here, is at this point, and other person is at this point, and other person is at this point. Each person now moves with a uniform speed v in such a way that K always moves directly towards L. K, L, M, N. Okay. This person moves towards this person always moves towards this person always moves towards this person moves always towards this person. Okay. Suppose in dt time distance traveled by the person will be also small. In dt time, this particle goes from this point to this point, but this particle also moves from this point to this point. Okay. Now this person also moves from this point to this point in dt time. This particle also moves from this point to this point in dt time. According to question, each person moves towards the person on next corner. Therefore, now this person should move in this direction and this person should move in this direction. This person should move on this line, this person should move on this line. Okay? Further in dt time, this particle goes from this point to this point, and this person goes from this point to this point, and this person goes from this point to this point, and this person goes from this point to this person. Now this person are moving along this. Okay? Here we can observe that separation between the person decreases, gradually decreases, and finally all persons meet together, moving like this. All persons will meet at center. Now according to question, the four person will meet at time. We have to find time taken to meet. Therefore, initial velocity in this direction and this person has initial velocity in this direction. Therefore, displacement, whenever two bodies are moving, then we take relative displacement, relative velocity, all quantities are relative, are taken as, all quantities are taken relative. Here relative separation is d, and relative velocity is the component of this speed, the component of this velocity in this direction, v cos 90 degree. Okay? We know that two particles has velocity in same direction, then we take their relative velocity which is equal to the difference of their velocities. Therefore, relative velocity should be equal to v minus 0. In this direction, this velocity is 0, and this direction, this velocity is v. Therefore, relative velocity will be difference of these two quantities. Okay? Along the displacements, all the measurements are taken along the displacement. Okay? Therefore, time taken should be equal to S relative upon V relative, D upon V. This is the answer. Okay? Therefore, time taken will be D upon V. Similar question. This is equilateral triangle and three particles which are moving with constant speed, and one particle moves towards the other particle, and other particle moves towards this particle, and this particle moves towards this particle. Okay? And this means one particle moves towards other particle kept at next corner. Okay? In this figure, we have to find time taken to meet. This is velocity v, and this is velocity v. We take component of this velocity in this direction. What will be component? This angle will be 120 degree, and separation and side length is a. Okay? This means that initial separation between two particles is A. Initial relative separation along this direction, therefore relative velocity will be also in this direction. Therefore relative velocity of particle, this is V cos 120 degree, therefore relative velocity V relative will be equal to V minus V cos 60 degree, 120 degree, because both are in same direction. Therefore relative velocity will be equal to the difference between them. This will be V cos 120 minus half minus minus plus. This will be V by 2. This will be 3V by 2. Okay. Therefore time taken should be equal to S relative upon V relative. Therefore A by 3B by 2. Okay. 2A by 3B. It can be pentagon, hexagon, octagon, any polygon. Okay. Now I am going to solve. In this question, another question can be in the form of how another question may be in which we have to find total distance traveled by the particle in time t. Total distance traveled by each particle, total distance traveled by each particle will be V into T, because each particle is moving with velocity V for time T. Therefore distance traveled will be Dt. V is the speed. The speed means magnitude of velocity. What will be the value? T is 2A upon 3V. Therefore 2A upon 3. This is the distance traveled in time t. Okay. Total distance traveled by each particle before meeting. 2A by 3. Okay. Now I am going to solve question number 6. A spotlight S rotates in horizontal plane with constant angular velocity 0.1 radian per second. The spot of light P moves along the wall at a distance 3 meter. The velocity of a spot. Suppose this spot moves in this direction. Initial position is this. As particle moves towards this position of particle is gradually decreased, and angle will also decrease. Okay. Here from geometry, tan theta is equal to x upon 3. This implies that x is equal to 3 tan theta. Here x is variable, theta is variable. As particle moves towards this, theta is decreasing. Okay. Therefore dx upon dt, as time increases but x decreases, therefore we put a negative sign, and on the right side tan theta, differentiation of tan theta is sec square theta, and d theta upon dt, operation by operator. Okay. Here as particle moves towards this, angle also decreases. Therefore, it will be negative. Negative sign cancel out on both sides. Therefore, dx by dt gives a speed of particle p 3 sec square theta d theta upon dt is omega. This is angular velocity. We have to find velocity of a spot p when theta is 45 degree. Velocity of a spot p when theta is 45 degree and omega is 0.1. Okay. What is the value of omega? 0.1. Therefore, sec 45 degree is root 2. Okay. Cos 45 degree 1 by root 2. Then sec 45 degree root 2. Root 2, the square of root 2, 2. 3 2 ja 6 means 0.6. This can be written as 3 into 2 into 0.1. Therefore, 0.6 meter per second. Okay. This will be 0.6 meter per second. This is the answer. Okay. Now I am going to solve question number 7. This question from projectile motion. The trajectory of a projectile in vertical plane is y is equal to x minus bx square, where a, b are constant and x, y are respectively the horizontal and vertical distances of projectile from the point of projection. X and y are horizontal distance and vertical distance. The maximum height attained is and the angle of projection from the horizontal edge. Here equation is given like this. Okay. If for calculation of maximum height, y should be maximum. Y will be maximum if slope will be equal to 0. Y will be maximum. I have already taught you in maxima minima chapter. Y have a maximum or minimum value if dy by dx, if dy by dx should be equal to 0. Slope will be equal to 0. Okay. Whenever in a question we have to find maximum or minimum value, then first of all we find dy by dx. And for maximum or minimum value of y, maximum value of y, maximum or minimum value of y, here we have to find maximum value. Therefore, we can write for maximum value of y, dy by dx should be equal to 0. Therefore, a minus 2dx should be equal to 0. This implies that x is equal to a by 2b. At this point, y will be maximum. Therefore, y max will be equal to a into a by 2b minus b into a by 2b whole square. Okay. Therefore, a square by 2b minus a square by 2b. 1b is cancel out. Therefore, this is 4. Therefore, a square by 2b. This is the answer. Sorry, a square by 4b. This is the answer. Okay. For b, we take LCM. For b, a square by 4b. This is maximum height. Now we have to find angle of projection. Y is equal to x minus bx square. This can be written as x into 1 minus b x by a. Okay. This can be written as in this form. Okay. A standard equation is y is equal to x tan theta into 1 minus x by r. Okay. Here it can be written as 1 minus x upon a by b. If we have to find range, then this will be equal to the value of range. But we have to find angle of projection. Compare both equations. Here tan theta is equal to a. Therefore, theta is equal to tan inverse a. Okay. This is angle of projection. This angle will be with x-axis. Okay. Maximum height is a square by 4b and angle of projection is tan inverse a. Okay. Tan inverse a. This got it. Now I am going to discuss question number 8. A particle is moving eastward with velocity 5 meter per second. In 10 seconds, velocity changes to 5 meter per second northward. The average acceleration in this time will be initial velocity is towards east. This is 10 meter per. This is 5 meter per second. And final velocity towards north. This is also 5 meter per second. Okay. The average acceleration in this time. Average acceleration will be change in velocity upon time interval. Okay. Therefore, change in velocity final minus initial. This will be final minus initial. This means that V2 plus minus V1. Okay. Minus V1 means direction becomes opposite, but magnitude will remain same. Therefore, resultant will be delta V. Okay. Resultant will be equal to the sum of this and this. Resultant is taken from tail to head. Tail of first vector to the head of the last vector. Okay. This is delta V. This is east, north, This is south, this is west. Okay, and this length will be equal to this length because magnitudes of velocities are same. Therefore, this angle will be 45 degree. This is north and this is west. Direction will be northwest. Direction of average acceleration will be along the direction of change in velocity. Therefore, direction will be northwest. Northwest, northwest. This option and this option are rejected. Now we are going to find magnitude. What will be magnitude? Delta V. Delta V will be 5 root 2. This is 5, this is 5. Hypotenuse will be 5 root 2. Okay? 5 root 2. And time taken is 10 seconds. Therefore, this cancel out and this cancel out. Therefore, 1 by root 2 meter per second square. This is magnitude. And direction will be northwest. This is correct. Okay? This option will be correct. Direction will be northwest and magnitude is this. Clear? Now I am going to solve question number 9. Maximum students and teachers solve this type of question by differentiation method. If you solve this question by differentiation method, then solution will be very long. This type of question can be solved by another method. Another method is, if a string is tight, then velocity of each point of that string along the string will be same. Here, this point is moving with a speed u, and this point is moving with a speed u, and this block will move in upward direction. Suppose this move in upward direction with velocity v. We take component along the string v cos theta. Okay, here a string is tight. Therefore, velocity of each point of the string along the string will be same. This point has velocity u along the string, and this point has velocity v cos theta along the string. Both velocity will be same. U should be equal to v cos theta. We have to find the speed of block. Therefore, v should be equal to u by cos theta, which is correct. U by cos theta. This is correct. Okay. You can solve this question by differentiation method also, but that method will be very long. Now I am going to solve next question number 10. A river is flowing from west to east. River is flowing west to east. This is east, this is west, and this is north, and this is south. Okay. River is flowing in which direction? River is flowing in this direction, from west to east. Okay. River is flowing in this way. At a speed 5 meter per second means Vr. Vr is 5 meter per minute, not per second. Okay. A man on the south bank. This is south bank. A man on the south bank. This is boy. Okay. Man on the south bank of the river capable of swimming at 10 meter per minute in a still water. This means that a speed of swimmer is given 10 meter per minute. Okay. wants to swim across the river in shortest time, he should swim in a direction. For shortest time, swimmers should swim perpendicular. I have already taught you. Okay. Therefore, direction will be towards north. Okay. This is correct answer. I hope you understand properly. Now I am going to end the class today. Have a nice day. Have a nice day. I will see you again tomorrow. See you again tomorrow. Namaste from my side.